Hi everyone, welcome to the lecture on ordinary differential equation. In this video, we are going to discuss how to test and solve the exact differential equation. Exact differential equation is very important. If it is in your syllabus, so you will find at least one question in your exam. And I will try to cover the different types of questions so that you will understand this topic and able to solve any question of exact differential equation. But if you have the doubt in the particular question, then you can share your doubt in the comment section or in Telegram, otherwise Instagram, so that particular question we will try to cover in our next coming video. So let's see our first example. Here, test the differential equation. This is our given differential equation for exactness. That means test whether it is exact or not, and solve if it is exact. That means first you have to check the exact differential equation. So what is the step? First you have to write the given differential equation in the form of m dx plus n dy. That means dx term will be first and then plus of dy term equal to 0. And here it is this term is in right side. So you can shift this term in the right side so that you will get equal to 0. So it is e power y plus cos x cos y dx, and dy term I will shift in the right side, so this complete plus term become minus. So minus in bracket sin x sin y minus x e power y dy equal to 0. Otherwise you can shift this term in the left side, that is also okay. So if we shift this term in the left side, so you will get the minus sign for this bracket. Okay. Now after that, compare this given differential equation with our standard form. So you will get the idea. Coefficient of dx is nothing but m. So in the second step, you have to find the m, function m. So it is a coefficient of dx. So if we skip this dx, whatever the remaining, that is nothing but our m. So here m is e power y plus cos x into cos y, and coefficient of dy is our n. So here dy if we skip, then whole term with this minus sign, this become our n. So here this n term is minus sin x sin y minus x e power y. Now if we multiply this minus sign, so you will get minus sin x sin y, and here bracket already contain minus, so minus into minus is plus x e power y. So first you have to compare, write down given equation in the form of standard form, that is a dx term first and then dy, and then compare this one with this standard form, so you will get m n. Now next step is important. To test the exactness, you must have to differentiate this m and n partially with respect to y and x. Means you have to check del m by del y equal to del n by del x. If it is equal, then we can say given differential equation is exact. So in next step, we have to differentiate this term partially with respect to y. So you will get del m by del y equal to, here when we are differentiating by y, so you have to keep x as a constant. So here it is a y term and e derivative is e power y as it is, plus x is constant, and if the constant in multiplication, keep it as it is. So cos x as it is, and derivative of y term, so cos y derivative is minus sin y. So hence it is a e power y minus cos x into sin y. Now similarly here n we have to differentiate partially with respect to x. So m is a coefficient of dx, but we are differentiating it by y, and here n is a coefficient of dy, so you have to differentiate with opposite variable, so it is differentiated by x. So when we are differentiating n partially with respect to x, so we have to keep y as a constant. So if this y term is constant, so we have to take derivative of this sign. So sin derivative is cos, and there is minus sign already is there. So minus cos x into sin y plus, here e power y is constant because y is constant when we differentiate x. So e power y I will write as it is, multiplication term is there, that's why, and derivative of x with respect to x is 1. So this is our derivative. Now check this result. Is it the same? Yes, if we write here e power y first, to e power y is positive and this term is negative cos x sin y. Now see here, exactly both derivatives are same, and if this del m by del y equal to the del n by del x, so it is nothing but the condition of exactness. So hence we can say the given differential equation is exact. And what is the question? Test the exact. If it is exact, we have to solve this equation. And what is the solution of this differential equation? If the given differential equation is exact, then its complete solution is integrate the m with respect to x keeping y as a constant and integration of n without containing x term. So here m we have to take whole complete function. So m is our e power y plus cos x cos y dx. Here we are keeping y as our constant term. Now plus n. N we have to take only the term which does not containing x. Now see here, this is our n term. This n first term containing x. So obviously we have to skip this term. Second term also containing x. That means again we have to skip this term. So both the term in the n containing x, and we want a term which does not containing x. So without containing x term is not present in n. That's why there is no term. So we will take 0 equal to integrating constant c. Now integrate this term. When we are integrating, so we can separate the integration. So integration of first term is e power y dx plus integration of second term, it is a cos x cos y dx equal to integrating constant c. And because y our constant, so I will write here constant y, and here also our y is constant. When our y is constant, so we know that in the integration constant term we can take outside. So yes, when we are taking the integration of constant, so we can write as a k is constant outside integration of dx, it is a kx. So when there is any constant in the multiplication, so that constant we can write outside the integral. So here e power y is constant, e power y we can take outside, remaining is integration of dx. And here constant term is cos, so we can take cos y outside, remaining is integration of cos x dx equal to integrating constant c. Now what about the integration of this term? Yes, it is a x. Cos y as it is, and integration of cos x is sin x equal to integrating constant c. Hence we get the solution of our given differential equation. So first step, write down in the standard form. After that differentiate m, it is a coefficient of dx, so we are differentiating by y, and it is a y coefficient, dy coefficient, we are differentiating it by x. If it is same, so it is a exact, and if it is a exact, then this is the complete solution of exact differential equation. So put the value of m keeping y as a constant, and n we have to take the term without containing x. If it is not, then we are taking 0. So hence we get the solution.